in Reaxys, what we can do is we can draw a specific scaffold. And I'll draw it in quick search. And we'll draw the quick scaffold. I'm drawing it using Marvin JS, but you can easily draw it in ChemDraw and copy and paste the structure into Marvin for further analysis. So what we'll do is we'll draw the scaffold here. And what we'll do is we'll perform a substructure search on all atoms, which will give us a greater diversity of results. So transfer over the query and perform a search. And as you know, Reaxys is an aggregator of multiple databases, including a substance database, a target database, a document database, reaction, and commercial substances database. So all of that result is evaluated in each of those databases. We're currently interested in the substance database, and to view the results, what we have is we have the series of results. In fact, we have 1,700 results, which conform to the scaffold of interest. And what we can do is we can see those 1,700 results interact on 122 targets. Okay? To get an idea of the potency of some of these, we can actually do this. We can actually look at what's called the px value of those specific substances. And the px value is located on the left-hand side of the filters, and it shows you a px of ranking from 10 to 11, which there's one substance, 9 to 10, which is 12. The px value is basically the negative log of the inhibition constant. So a px value of less than 9 is subnanomolar. A px value of less than 6 is submicromolar. Okay. To view the action of these substances on these 122 targets, we can go over to the bioactivity visualization table, click on that. It opens up a new window which shows on the left-hand side all 1,700 of those substances listed on the y-axis and all 122 targets listed on the x-axis. You can use the navigator to screen different regions of the bioactivity visualization table. And you could also see that there is gray dots on top of columns in the y-axis and gray dots to the left of rows on the x-axis. The gray dots correspond to the number of targets, the number of substances that interact with each specific target. And likewise, the dot on the x-axis corresponds to the number of targets that are tested against one substance. You can see in this table that there's a lot of white space. Okay? A suggested hint to remove some of that white space is to go back in the Substance tab, click on View More in the PX value filter, and under the No Entry Given, we can exclude those data points from further analysis. So now what we have is we've gone down to 283 substances that act on 71 targets. In the bioactivity visualization table, okay, what we see is we see much less white space, and we sort of catching a glimpse now of some different targets that are acted upon by these scaffold-containing substances. For example, we see a series of substances that act on the hydroxytryptamine receptors. We see a series of substances that act on dopamine receptors. We see a series of substances also that act on sodium-dependent dopamine, noradrenaline, and serotonin transporters, as well as the toll 7, 8, and 9 receptors. Okay. What we can do now is filter these for just those specific targets that are most reactive with these scaffold-containing substances. And to do that, you can click on the individual targets which are acted upon by most of these substances. And we can limit the table to just those targets. And now what we have is we have a very clean table of different substances that act on specific targets. In addition, the great thing about this is we can actually click on the individual cell it opens up a new window which gives you back the official reference of how that px value was determined. A px was determined at 1.6 nanomolar, which corresponds to a px of 8.8, using the IC50 parameter. We can adjust these columns for the individual cells. In addition, we can also change the settings of the table. Okay, so for example, we can change the x-axis from targets to, if we were interested, we can look at cell lines that were used to evaluate these references. In addition, we can also export these data, okay, using the new layout. And what I have is I've already exported this. And you can see here is the table that we have, and each of those substances are listed on the y-axis and the targets on the x-axis. So what you export is the exact table that what you see on the screen. And with that,